Yes, sir. As a part
Yes,
of Euclidean.
yes, I think it will help you a lot if you know the properties of a triangle. It will help you a lot in Euclidean geometry, big time.
Okay, sir.
It will help you a lot because yes, in Euclidean geometry, most of the cases we deal with Euclidean geometry. I mean, we deal with triangles.
Okay,
So
sir.
it will be wise for you to play around that part.
Okay, sir.
So so are you fine with Euclidean geometry, the proportionality theorem? Let me just quickly share my screen now here. Are you fine with that?
Not entirely, sir.
Oh, okay, okay. Let me just quickly share my screen. Were you attending those previous lessons that we had last time before?
Yes, I was.
Oh, okay, cool, 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 cool. And then let me, can you see my screen that side?
Yes, yes, I
Oh,
can.
okay, so I think just to test you if yes, indeed you are fine with Euclidean geometry for grade 12. Uh, let's say I want some blank page here that I can use. Oh, let me just use this part here. Uh, can you see the triangle that I've drawn now there? The blue one.
Yes, sir. Yes,
Oh,
sir.
okay. I've got triangle A, B, C. So, and then we've got D, E right there. So I'm asking you now, does the proportionality theorem apply now in this triangle?
Yes, sir.
Why?
Because AD over DB is equals to AE over EC.
I kinda disagree to you. I don't really agree to that. Uh,
Should there be parallel lines present?
Yes,
Okay.
in order for you to say now proportionality theorem applies to this triangle, there should be some parallel lines. So you should be sure that this line is parallel to this one. Then if you are not sure, there should be some statement that states that thing that DE is parallel to BC. Just like if I can say now, given a triangle ABC and given a line DE that is parallel to BC, that's when now you can conclude by saying, oh, now proportionality theorem applies here.
Okay, sir.
That does it make sense?
It does, sir.
Oh, okay. Then you will let me know if I'm a bit fast or I'm a bit slow.
Okay, sir.
Oh, because I might be slow, I might be fast. Oh, fine. Then I've got some question paper that I would love us to go through. Let me just quickly run to it, work through it. Uh, how is it going though with your metric coming?
It was going, it's a bit like bumpy, but it's fine.
Kupambulele. Oh, but I believe in you guys. I believe in you guys. You guys are just going to manage, eh?
Thank you, sir.
I believe in you guys. I mean, I can bet with you guys. So, hey, with not with my money. My money is gonna leave me if you guys are not winning there.
That's true, sir.
Yes. So let me just quickly share my screen for this other new document. Let me stop sharing this one. I now want to share this one and then share. Can you see my question paper right there on the screen?
Yes, sir, I can.
Oh, oh, okay. Then there's this question I want us to. Can you see that question 9 there on the screen? Come in.
Yes, sir, I can.
Okay, thank you. Then come in. Just never mind my comments there. It's just a little busy wherever I am now. So we are having this question 9 here in front of the screen. It is saying in the diagram the triangle now DEF, and then you can see the triangle DEF, and then they are saying is drawn, and then the line GH intersect. You can see the line GH is this one intersect
Yes, sir.
DF and D and EF and G and H respectively, meaning G for DF and H for EF. Okay, fine. And then, but this doesn't matter. Shouldn't
Yes,
have.
sir.
And then now, these matters. In that triangle, GH is parallel to DE.
DE.
Already now, you know and you are convinced that now you can use proportionality theorem, right?
Yes, sir.
Okay, and then we are given some ratio that we are going to use. Oh, nice. Then they're saying this ratio is for GF. What is GF? GF is for
Yes.
this part. We can say this part for GF is 2A.
Two.
2A. Remember, I said maybe 2. I think I said, if you still remember, you should introduce that variable for this whole site. So for DG is 5. Then if you already give the site, the whole site, a variable A, then also for this one needs to be A. You can't say this is A and then this is B. For that whole site, the variable needs to be A. Do you understand
Yes,
that?
sir.
Okay.
Yes, sir.
Now let's go to the question that is saying, and now write down with reasons the value of HF, which is this one. Oh, nice question. 2 marks. Oh, this 2 marks I think is for free. I believe in you with this one. How do you think we can find GF over EH?
Okay. G find what? GF over EH.
Oh no, sorry. So I wanted this
HF.
one. Yes,
HF.
HF over EH. I'm sorry, my bad.
So GF over FD
Or you are saying GF, you are saying
over
over.
FD
Okay, you are saying GF over FD. Okay,
is equals to
is it
HF
is equal to HF
over FE.
over FE.
Proportionality theorem.
Oh, okay. I love this. Then you state your reason. I think a reason is a mark. If I was the marker and then I have to mark you guys and then I see no reason, I don't think I can give you full marks. Then GH is parallel to DE. Then this
Yes,
is the
sir.
mark. Yes. Then now you substitute, right?
Yes, sir. Yes, sir.
Yes. So now for this question that we are required to calculate now, how do you think we can play around proportionality theorem to find this one?
Um, we know that HF.
Can I quickly
Um,
please remove this mess? We know, what?
I think we know that HF
We
and
know,
GF is going to be equals to the same value. So
okay. So you're going to say, I mean, HF over EH. This is equal to that given thing GF over DG. Do you agree?
yes, sir.
2 over 5. Then you're not done, remember? Then you give your reason. Prop theorem.
Proportionality theorem.
Then you state your parallel lines. I mean, GH is parallel to DE. Then you are done. You are done. You are done. Then now
Yes, sir.
let's jump into the question number 912. Now we are given that EF, where is EF? Or this portion here, we are given that if is 21 centimeters. How many centimeters do you think the length of EH will be? I'm asking this one now. I'm giving this one to you because I believe in you that you're a mathematician. You can tackle this question. What do you think?
So, sir, I would say, um, okay, F, HF over,
Over EH?
huh?
What
Um,
are you, what
wait,
are you saying?
wait, sir, wait, sir, wait, sir. Okay, I would say. HF
H,
over
okay.
HF over
Mm-hmm.
EF is
Okay.
equals to EF over DF
So you are saying HF over,
over
you are saying
EF.
H over
EF
EF. You are saying, okay,
is equals to GF
is equal to GF over
over DF.
DF. Okay, you are saying this.
Prop
Okay.
theorem.
Okay. Oh, I love hearing those reasons. Prop theorem, and then now
And
you say
then
parallel line.
GH is
E
parallel
is
to
to parallel.
DE.
Yes. Okay, 100% correct. Okay. And then
And then we know that HF is 2, so we substitute 2
HF, you are saying is 2. Okay.
over um EF is
Mm.
21
Okay.
is equals to,
Is equal to.
oh no, but it's wrong.
Yes, it's wrong. Okay.
It's wrong.
I
I
think
forgot
I'm glad.
EH. I forgot EH.
I think I'm glad that now you saw your mistake. So what should I do? Should I rap? Should I?
I was supposed to say EH over EF, not HF over EF.
Okay, then let's just rewrite that. So should I rub the numerator?
Yes, sir.
Okay, and write what?
EH,
So you want me to write E H
H. But then
over,
it also changes GF. So
yes,
GF becomes DG.
DG, yes. So this becomes
DG.
DG. Okay.
Yes. So we substitute EF, we leave it as it is. So it's EF.
So should I say EH, we leave it as it is?
EH, yes, we leave it as it is. Sorry. H
Okay. Over EF.
over
EF
EF
is
is
then,
21
okay.
is equals to
Okay.
DG is 5,
DG is,
5.
DG is 5. Okay.
And then DF is 7.
Okay.
And then we can cross multiply.
Then we are going to have 7 EH is equal to 21
Cross
times
through.
5. 21 times 5.
5 times 21 is
I
105.
I get 105.
Yes,
Then
sir.
divide by
Divide
7.
both sides by 7
EH is equal
is
to,
15.
divide by 7. I get 15. Okay. Okay. That's what we get. Then I should have went this way for it. I'm not sure if that is the correct length for EF, because we use the
It's
length
centimeters.
and ratio. Sorry?
It's centimeters, 15 centimeters.
Oh, centimeters. Then my goal, the way I should have went for, I think I was going to do this way. We said GF, which is this one, we said it was 2A. We said that one DG 5A. When we move to this side, this will be 2B, that will be 5B.
Mm.
Therefore, this whole thing will be 7B. Do you agree to that?
Yes, sir.
Okay, then now we can say, I think 2B is equal to, cause oh, I mean, no, no, not 2B. This 21 is for EF, for the whole, right?
Yes, sir.
For everything. So I would say 7B, because 7B is for everything, is equal to that 21. Therefore, my B is going to be equal to 21 divided by 7 is 3, if I'm not mistaken. And then I have B. I have B there. And then now EH is just going to equal to EH, you can see, is this part, 5 times B. What is B is 3. Oh,
3.
is the same answer. Oh man, good approach. Centimeters. Then I can give you full 2 marks. But then there are many ways to kill a cat. Then, oh, I killed it this way. Then you chalk it. I love
Yes.
seeing this. I love seeing this. Okay, thanks. Then let's now just quickly run to the next question, 913. Now we are required to write down the triangle which is similar to the other triangle FGH. Yes, what do you think with this one? Similarity.
Triangle FDE is similar to triangle FGH.
You are saying FDE.
DE.
FDE is similar to FGH.
FGH. Yes, sir.
Oh, okay. Oh, okay. Okay.
F is the common side, common
F is the
angle.
common angle, yes. Then that's it is just what one mark. It deserves those marks. It deserves those marks. Then let's just move now to the last one, 914. Hence now calculate GH over DE. Yes. What do you think?
So okay, can I write
I
it
mean,
down first? Let me. Okay, so I think it's going to be GH GH over DE
okay. You are
is
saying
equal to.
GH over. Okay, can I please just quickly erase this mess so that I can write
Okay.
down everything that we are saying there? Hi, my eraser is a bit slow. Forgive me with that. Uh, oh, it's now back. So you are saying GH
GH over DE
over DE.
is equal to FG over FD.
You are saying okay, GH over DE. You are saying is equal to GF.
GH over DE is equal to FG over FD.
FG over FD. You are saying that. Okay.
I
Okay.
used the thing is I used triangle FGH is
Yes.
similar to triangle FDE.
Okay. And then from here you just substitute.
No, and then I said is equal to FH over FE.
You are saying this is going to be equal to FH
H over
over
FE
FE
is equal to 2 over 7
is equal to 2 or 2 over.
over 7.
Oh, I think my handwriting is horrible. 2 is like 7, 7 is like 2. Uh, so you're saying it's
2
like
over
this.
7. Yes, and then proportionality theorem. I think, so I'm not sure about this one.
Oh, you think, oh, I thought, yo, oh, okay. Then you are saying your reasoning should be prop
Uh, Theorem.
theorem, reason, and then where are the parallel lines? I mean,
GH is parallel to DE.
GH is parallel to DE. So now you want to say now this GH over DE, can you relate that these sides with this one using proportionality theorem? I think I'm lost. I'm lost here. Can you just please elaborate this relationship here? Mm-hmm. Just this relationship here from GH over DE. How is it possible that this? Oh man, are you still there? What happened? Hey, hello.
About that.
Oh yeah, you are back. You are back. At least. I was
Yes.
wondering where are you going, but at least you are back.
My
So,
network was a bit of a problem.
oh no, it's fine. It's fine. It's fine. No problem. No problem.
Okay, sir. And then you were saying,
So I was asking like how now did you move from GH over DE is equal to, I mean, FG over FD?
I moved from that. I first wrote down that triangle FGH is similar to triangle FDE. So I know that like you can, I don't know how to explain this, but you can using the thingies, the properties of a triangle, you can actually say FG over FD is equal to GH over
Oh,
DE,
let's,
and then
let's,
GH over DE is equal to like that.
let's quickly have a look on the properties. Can you still see my screen that side?
Yes, sir.
You see some textbook? Oh, you still seeing that question paper?
Yes, sir.
Textbook.
I'm seeing this, what you're
I'm
displaying.
scrolling.
Yes.
Oh, better, better. Where is the similarity theorem? Oh, here it is. Here it is. Here it is. So there is that those angles that are equal. Those
Yes, sir, like this. I did it like that.
okay, you did it like this.
Yes, sir.
So
Like over
I
D.
had I now I wanted to hear that solidity of your confidence, but it seemed like you were not sure.
Yes, I'm not sure, sir.
You're not sure, ne?
Yes, sir.
But yeah, there it is now. If now you are sure that those triangles, that if you are sure that they are similar, then now you can conclude now by saying this.
Yes, sir.
Yes. Oh, then if that's the case, are you satisfied with this?
Yes, I am because we had proved that the triangle we didn't prove, but we did say both the triangles were similar in the previous question. So that's why I used
Okay. I have this question now. I have this, but I think this is grade 11 geometry. This one. This one.
mm,
But I think you can play around these questions, man. I believe in you. You
okay.
can just we can just browse them without writing and have some conversation on this. Oh,
Okay.
I love this technique, DRCPT. Wow, then diameter on the first
Dr.
circle.
Cape Town.
Yes, yes, Dr. Cape Town. I love this a lot. So on the bigger circle, using the diameter, we already can see that R2 is 90. Okay. Also in the smaller circle, we can see that this angle is it's 90 degrees. Then
Yes,
I think by saying that we can also we know in fact we know according to theorem 1 that this is a chord, this is that line drawn from the
sir.
center of the circle, then it intersects with that chord at 90 degrees.
Yes,
So
sir.
with that, I think we have proven that LLT, which is this one. In fact, we are not gonna need this part here. I don't know what am I doing here, but we have proven now that this line LT, which is this one, is parallel to the line PR, because now this one is the converse of that reason that is saying these are the alternate angles. They form something like a Z. Then now
Oh
we
yeah,
can.
so I can see
Oh,
R2 and
you didn't
L.
see it. You didn't see it. Oh, I,
I
I,
see now, sir. I
oh, I'm
see.
glad. I'm glad I put you to some. I'm glad I put you to some spotlight. Then if now I'm saying to you, you were given that these lines are parallel. If you were given, you can conclude by saying this angle
Angles
is
are
equal to
equal.
this angle. Your reason being alternate angles, then
Angles.
you state your parallel lines, right?
Okay,
But
sir.
if you are required to prove something, if you are required to prove something, now you are required, in this case, we have a case whereby we've shown that this angle is 90 degrees. We also have shown that this angle is 90 degrees, right?
Yes,
So
sir.
we've shown that this forms something like a Z shape.
Yes,
Now,
sir.
you can write your reason being the converse of alternate angles. Now, instead of, because this is a converse, you are doing the opposite. Instead of stating those parallel lines, you state your equal angles. that now angle R2
R2
is equal to that angle L.
L.
Then remember that angle, you indicate it by just putting that thing on top of the letter to state that it's an angle. Because if I was the marker, if you say this is angle R2, I can give you incorrect. Because I'm not convinced that this is an angle. You need to convince me with that sign that this is an angle. Are you
Yes,
happy?
sir.
Okay. So now you are fine with this one?
Yes, I am.
Okay, okay. Let me quickly rub this mess here on the bottom of this page. Then now question 9.2.2 is saying Lormo L. Where is L? There is L on top, and then
O
O R
R
and M.
M.
It's exactly quadrilateral. If now LT, there is LT right there. There is LT. Let me change the color. There is LT. If this line, now if this line and OM, if these lines are parallel, now you should prove that this is a cyclic quad. I mean, what do you think about what is the cyclic quad first? Let me ask you that.
Okay, a cyclic quadrilateral.
Okay.
I know that the opposite angles are supplementary, so they add up to 180.
I mean, yes.
And then I know the is it exterior angles? The
Ex-
exterior and the one like for example, um yeah, the one is it I forgot what it's called, but like the exterior angle yeah, that one and that one.
Aha.
It give
So,
us
So,
yes.
is there anything that you're noticing with this shape of the cyclic quad?
L O R O.
Except what you just said now with the
Okay,
cyclic quad.
so
Wait, let me just ask you this. Is this a cyclic quad? Is this a cyclic quad? This is the corner on the circumference. This is the corner on the circumference. This is the corner on the circumference, the corner, and the last corner on the circumference. So I'm asking you now, is this a cyclic quad, the orange one?
I don't think so, sir. No.
Why don't you think so?
A cyclic quad has four sides.
Oh, yes, 100% correct. Yes, you need to note that with a cyclic quad, it has got four sides, four corners. So all those four corners are going to be on the circumference, right?
Yes, sir.
Yes, thank you. So now, I'm not sure if I can demonstrate well this on the here on the screen, but I want to demonstrate something. Uh, can you see this thing here? This thing. I think this thing you can. I wish I was there and holding some paper, but this thing. If this was the circle.
Yes, sir.
Thi- this was going to be a cyclic quad, right?
Yes, sir.
Then now, with a paper, you can fold that paper until the paper gives you this shape. This shape.
A bow tie. Yes, sir.
Yes, a bow tie shape for that thing for angles in the same segment. Yes.
Yes, sir.
It
Yes.
definitely can give you something like this. Now it takes us to that extensions that we used to play around when we used to play around the grade 11 Euclidean geometry, whereby we said this angle is equal to that angle, the reason being angles in the same segment. Same
Segment.
applies with this angle is equal to that angle.
And that one. Yes, sir.
Yes, angles in the same segment. So this you can say this is a cyclic quad because we moved from that to this. So this is a cyclic quad. Do you get that?
Yes, sir. I do.
Okay. So now I think I gave you enough clue to prove that lorm is a cyclic quad. I mean yeah, I think because now can you see where lorm is?
Yes,
Lorm
sir. I can.
Lorm is this part, is this part, right?
Yes, sir.
Yes. So it's either now you're going to prove because now we don't have that shape. That shape that is like this. That is like this.
Yes, sir. We have
Hence,
the
that
bow
is
tie shape.
exactly. You have the bow tie shape. So we just have to prove now that this angle is equal to that angle, or this angle is equal to this angle. So over to you, ma'am. How do you think you are going to prove that?
I would say angle LOM. So O1 basically.
So you are saying O1, okay?
O1 and M1
Yes.
is equals to 180.
So you are saying you are saying
M1
M1 is equal to O1.
plus
Yes.
plus
Oh,
O1.
plus. Oh,
Yes.
plus. You are saying plus. I didn't hear this. I'm sorry. You are saying plus. Okay.
O1 is equals to 180.
Okay. Okay.
It's because opposite angle. No, is it?
I'm just waiting for you to
No,
say
no,
whatever
no,
you want
say,
to say with
no, no,
confidence.
say, no, say.
Now
I
you
think
see
that's
where you're
right.
wrong. Because you can't
Yes,
say,
so O1 is equals to R1, not O1 and M1.
okay, you are now saying O1
One is
is equal
equals to
to
R1.
M1. Okay, reason being
R1, say, R1.
R1. Oh, I'm
Yes.
sorry. I'm sorry. I didn't hear you well. R1. R1. Okay.
And then I think it's angles in the same segment.
No. Oh, okay. I agree. I agree to that. Only if it was given or we were given that this is a cyclic quad, but we are not given. That's
Oh, we're
what
proving.
we want to prove. Yes, ma'am. Yes. That's what we want to prove. What do you think? Oh, 5 marks. That is a lot.
Yeah, it is a lot.
Yo, that is a lot. So let me have a look. Uh,
So we
I
know that I think
firstly,
yeah,
I think we were told that these
LT
lines are parallel. These lines I mean OM, which is this
and
one,
LT
and LT are parallel.
is
This implies something. Look, and now when I come to you, maybe I can say to you, since these lines are parallel, let that angle maybe be x. If that is x, then this will be x2, right? This will be x as well,
yes,
this one. Then now, let's try to work around our maths and see how we can make this angle be x as well. This angle right here. Can you see this angle here?
yes, sir.
If we can get this angle as x, this one, then now we can conclude using the converse of angles in the same segment, and then we state the equal angles.
Okay, so I see now M1 is equal to O1 because of alternate angles. Oh
Uh,
my,
so,
I don't
hmm?
think were we given that OL and RM are parallel lines. Are
OL,
parallel.
what is OL again? OM, right? No, we are not given with OL
Yeah, we
and
are
T. Yes.
not.
Oh, yes, you can't. Yes. Yeah. What do you think? Is there
Let me
is there
see.
anything that is
TL
coming up?
O and L
I
O
know you're gonna come up with something.
L. Let me see L and O.
Look. I see something. I see something. Look at this. We said now let angle T be x, right? You write that
Yes,
maybe
sir.
on your paper. Let angle T be equal to x, right?
Yes, sir.
Now, do you agree to me if I say angle M1 is x, reason being corresponding angles because LT is parallel to OM?
Yes, sir.
Okay, I think that's 2 marks. And then now I am going to say to you, there is this angle between on the smaller circle. This is a chord on the smaller circle, right?
Yes, sir.
And then this is a tangent on the smaller circle. Then that is an angle between the chord and the tangent, right?
Yes, sir.
And then that angle is equal to the angle inside the triangle that is opposite that chord. Can you see it? That this angle now is x using tan chord theorem.
Yes, sir. Yes, sir.
Then now this angle is equal to this angle. Therefore, we can conclude by saying lorm is a cyclic quad. Reason being the converse of the reason angles in the same segment. Then you state your angles that are equal, that are in the same segment.
Okay, sir.
Can you see it?
Yes, I can.
Are you happy with the explanation?
Yes, sir.
Oh, okay, thank you. If don't be shy to just say no, say I didn't understand that. I don't mind re-explaining anything more than I don't know infinity times. I can.
So,
So
sir, like, how was L equals to T,
how
though?
what?
How was L equals to T? Like, T was X.
Okay,
How did L
let me.
become X?
We said this angle is x. I get this one right.
Yes, sir.
It's x. So can you see this circle? Can you see this circle?
Yes, sir.
Yes. Then there is also a tangent to that green circle, right?
Yes, sir.
And there is a chord to that circle
Yes,
that
sir.
that makes this triangle. And then when I explained a tan chord to you guys, I think I said if this is a tangent and then this is a triangle inside the circle, I said to you guys, this angle that is between the tangent and the chord, can you see this angle?
Yes, sir.
This angle is going to be equal to the angle that is inside the triangle, but that is the opposite one to the tangent. So this is the tangent. The angle that is opposite to this tangent is going to be that one.
Yes, sir. I see that.
So this angle is equal to this angle, reason being tan chord theorem. Do you agree to this?
Yes, sir.
Okay, thank you. Then now, this angle here, okay, to this greener circle, this is a chord, right?
Yes, sir.
And then again, this is a tangent.
Yes, sir.
Now this is the angle between the tangent and the chord.
Oh, yes, I see it. Yes,
And
sir.
then this angle is going to be equal to the angle that is opposite the tangent. Now can you see it?
Yes, I see it.
Yes, then now, because we already said this is x because of corresponding angles, then this now is equal to this. You can conclude using the bow tie converse because we are proving. Now you're going to use the converse of this bow tie.
Yes, sir.
Does it make sense?
Yes, sir. I understand.
You sure?
Yes, sir.
Okay, thank you. Then the last one, which is 923. This one is saying now, do you still remember what is meant by this term, bisect?
Bisect. They say
Yes, but
LN.
yeah, like what can you tell about the word or a term bisect?
I'm not sure I remember, say.
Okay, so bisect, I said, if I say, no, I almost made an example using you and me, but no, that's wrong. Let's say, let's say there's part A, right?
Yes, sir.
Part A is this thing here, is this thing. Or in fact, a part A, let's say this part A is a bread, right? Part
Yes,
A,
sir.
part A is a bread. Let me just say part A is a bread, right? And
Yes,
then
sir.
part B is a knife. This is my good knife here. A knife. That is part B. So
Yes,
I'm saying the knife bisects the bread. If the knife bisects the bread, that means we are going to have two equal halves of this bread.
yes, sir.
Can you hear now what is the meaning of bisect? When you
Yes, sir.
bisect something, you divide that thing into two equal parts.
Yes, sir.
Yes. So
Understand.
so now if this is angle O, I mean L, that is OLR, and then there is line LN here, it bisects. It means that if this whole angle was x, then OLN, it bisects that. We are going to divide that angle 2x into 2 half so that we can have x on this
And X.
portion and then x on this portion. Do you understand this?
Yes, sir.
Okay, nice. Then now let's quickly rush to the question. Uh, Now where's OLR? Oh, there it is. There it is. There it is. Here. So now we want to show that this line, we had the x, so we want to have that half x on both sides. What do you think on
Yes,
this?
sir.
Yes. Now what do you think on this?
Okay, so I
Yes.
think we can see that OL is equals to
OL.
OR, which is the radii. I don't know if that counts though.
OL and OR.
Yes.
Yes, I was going to agree. Yes, if we had the existing line OR here, but I think now it's not there. So,
So are we not allowed to draw like imaginary lines, those dotted lines?
oh, okay, okay. Okay, let's then draw and see how it can work. Okay, and then now what do you think?
So and then I'm not sure anymore.
Oh, okay, okay,
Sure, I'm not sure.
okay,
But okay, since they're both ready, so it
okay,
means that angle L and R are equal.
okay. I agree.
Yes, and then also um
Mm-hmm.
uh
Mm-hmm. You said that is X, and this is this 90 though? No, we can't say. You can't say. Okay,
okay,
but
since they are equal, I think I don't know, say no.
so should I now wrap this?
Yes,
Okay, and then give you some time maybe to think. Mm-hmm. Mm-hmm. I'm still thinking.
yes,
Oh, okay, okay. No, no, it's fine. No, no rush. I mean, you have the whole of time, the whole time, the whole day. I mean, time is ours. We can.
I'm not sure, sir. Not
So,
sure.
so let's say now you were in a paper. Were you going to give up just like that to this question?
No, say no.
You see, it seems like you were going to give up. It's a sin. It's a sin to give up, I think, on a paper. I mean,
Yes,
these are very, very good marks, guys, for you, just for you to just give up on them.
okay, can't I say because I already said OL is equal to OR as ready.
Already
So
said. Oh,
since
so should I reconstruct that line?
yes,
Okay, okay.
so since we know that LORM is a cyclic quad.
But
Um
okay, okay. Yes, we said that is a cyclic quad. We said so.
yes, we can say that angle L and angle R are equal. And then we can also say that L4 and L3 are equal, which makes
L, yeah. So, pardon? Okay, we said now this is a cyclic quad. So you said we should construct some things here. So I constructed this. I think this can help us a lot here in this thing. And then, so you are saying,
So
can
O angle OLM.
OLM, OLM,
Yes. So L.
O O OLM, where is it?
So
The-
L.
To L. I see
L
O
L4 and L3.
L3. You mean
Yes.
this angle?
Yes. Is
Yes.
equals to ORM. So
Is
which
equal
is
to ORM.
M. So the whole of R.
This one.
Is the whole of R. Since we constructed the line OR.
Okay,
So from
you are saying is equal to the whole of R.
no, ma, that wouldn't make sense.
You see?
See,
Mm-hmm.
I don't know. I don't know.
Gave up? It's still early to do so. I think let me just try to see if we can work out something. But this question is tricky, honestly speaking. Uh, and 4 marks, but 4 marks is a lot. Yo. You can't afford to lose those marks. They are a lot, honestly speaking. And then let's maybe say M1. M1, you can say 2 times. M1. Can we see that M1 is angled at the center?
Yes, I can.
Can you see that?
Yes, sir.
And look, when we only focus on this circle, this circle, the orange one,
Yes, sir.
this is angled at the center. That is angled at the circumference. Can you see that?
Yes, sir.
Can you see that?
Yes,
So,
sir.
what can you say about angle L3?
Mm, isn't it the theorem that states that angle at center is equal to two times the angle at the
Abs-
circumference?
Absolutely correct. And then now, what is the size of angle L3?
Wouldn't I have to calculate M1? It's two times ML.
Oh, okay.
M1. Two times
Okay.
M1.
Yes, we have okay, but we have M1, I think, by the way, but you can do okay, you can work something as a mathematician. Maybe let M1 be angle A, right?
Yes, sir.
If that is
So
true, then you can say M1 is equal to 2 times L3. But
three
this is an angle, this is an angle. Reason being, angle at the center is 2 times
equals to
angle at the circumference. This is your reasoning. Then what is M1? In this case, M1 is A is
A.
equal to 2 times
A.
L3. And then
Yes.
angle L3, now we can see that angle L3 is A over 2, which is 1 over 2A, right?
Yes, sir.
Can you see that?
Yes, sir.
Okay. Then now you can just say sorry, this angle, okay, you can say LORM is a cyclic quad and pro proved this, right?
Yes, on the previous question.
Yes, so if that is a cyclic quad, you can say now the whole of I mean we can just say the whole angle OLR, that whole angle is equal to angle M1, right? Is
Yes, sir.
equal to angle A, reason being angles in the same segment, right?
Yes, sir.
Yes. Then if this whole angle is A and this angle is A over 2, what is the size of this remaining angle? It's A minus A over 2.
Over 2.
Then we are getting 2A minus A over 2. 2A minus A is A over 2. Then also for this angle, we are getting A over 2. Also for this one, we got A over 2. Therefore, we have proved that this whole angle is A. Then this line divides this angle into A over 2 and A over 2. Therefore, line LN bisects OLR.
Okay, I see it, sir.
Do you understand it?
Yes, I wouldn't have thought of that though.
But yeah, I agree, Yona. It was bit horrible. It was bit challenging.
But I see it,
You sure?
yes, sir. I'm sure.
Okay. Then this is the proof. I think, I think you guys need to, but we will get there. We will get there. I think we are going to start with similarity value. I think on Sunday. Oh no, not Sunday because we still have to play around these questions. But we will get there to similarity after we are here. And then let me just try to find another question. I don't even know. Let's maybe do this. And then. What is the other question that I can go to? But maths is nice, ne?
No, it's not.
Not. Oh, maths is
It's
nice.
not.
But you guys should love maths. Maths is nice. You will love. I love maths, honestly speaking. I don't wanna lie. I think maths was my favorite subject in matric.
No, say, it could never be my favorite subject.
Why?
It's tiring.
Are you guys even applying?
Yes, we are, say.
Oh man, nice. You guys should apply as early as you guys can. I mean, this time is moving fast, eh? They tell maths paper too. So you want to be a mathematician, I think. I mean, oh, please.
No, say.
Yeah, just apply for maths and just go. Maths is nice and fun. And then I have got this question. I wonder how it is. Is this person even here? Hello, Moruma, can you hear me?
Yes, sir, I can hear
Oh,
you.
oh man, my bad. I'm sorry. I mean, a lot just happened this side. I think it's either network or electricity is jealous today.
It's okay,
But
sir.
but let me just quickly sort something out here and share my screen quickly. I was asking about application you applied for maths.
No, sir, I didn't.
Why?
I don't like maths, sir. You.
Oh man, I get hurt when I hear someone saying I don't like maths. I
I
mean,
nobody should like maths.
how is it possible for a person not to like maths? I mean, maths. Oh, maths is fun.
It's not.
Oh, maybe with you it's not. But please just develop some love for maths because you're still going to see maths a lot. I don't wanna lie. It metric. I mean, especially Euclidean geometry and trigonometry. I think you should know those topics because they are there. They are there indeed.
Yes,
So
sir.
let me just quickly share my screen. I think now it's 4 o'clock. Would you mind if I use some extra minutes to continue a bit with the lesson?
I don't mind, sir.
Oh, I don't want you to hate me and be like, oh, say hates me, and then because there's this high
Come on,
school
bye.
I love going to in the back there
You
in my
can do
area.
one. You should say.
Oh, okay, okay, okay. Thank you for allowing me to do that. Let me quickly do so. Let me just. Hello, can you hear my screen? Can you see my screen that side?
No, sir, not yet. Yes,
Okay.
I can. I can.
What are you seeing that side?
Zoom.
Oh, Zoom. I don't want this Zoom. I wanted to share something. I still seeing some Zoom.
No, sir. I see all papers, sir.
Oh my God. Let me stop sharing and I will just reshare again. And then stop sharing. Why is stop sharing? What are you now seeing?
A question paper.
Oh, nice, nice, nice. This is the question I want us to go through. So we have got this. I think this is the simplest question. Oh, but you've got this question in front of the screen there. So question 10 in the diagram below. F lies on ED. ED. Where is ED? Okay, there is F. And AB. G lies on ED. Okay, then whatever is a straight line. BFA. I think we did this question, if I'm not mistaken. Maybe I did with someone. Then BFA far is parallel to DC. Then we are given those lengths AB, BC, EF, EB, and BF, or FB, I mean. So now I'm asking you, with reasons, determine the value of EF over ED. What do you think now?
Okay, firstly, I would determine the similar triangles. So I would say,
They're saying, oh, you
um,
say,
yeah, I would say, okay, without the similar triangles, I would also say, EF over ED, EF
EF,
over
EF over
ED
ED, yes,
is equals to EB over,
EC.
no, EB.
Mm-hmm.
Oh yeah,
EF,
EB
EB over
over
EC.
EC.
Yes.
Yes.
Reason
And
being,
then, oh
no,
yeah,
it's done.
proportionality theorem.
Yes. Now you substitute.
Yes. But FD is parallel to DC. So, and then
Yes.
we can substitute that. We were given EF as 16,
Yes.
and then we were also given ED.
They're given
No,
EB, I mean, I think EB we are given as 10.
yes,
And then
EB.
now our EC is EB plus BC.
What's
Can you see that now? The EC is EB plus BC is 30.
EC is equals to what? EB plus
BC.
BC. Yes, I can see that.
Yes, yes. Now determine the length of ED. Can you?
The length of ED.
Yes.
Okay, the length of ED, I would from our previous steps here, I would also use EF over ED is equals to no, yes, is equals to EB over BC. And then I would substitute the values that I was given, cross multiply and get ED.
So you would say EF. I mean, let me just quickly write that. You would. I think if I hear you, you are saying uh, E.
EF
You're saying EF. Okay.
over ED.
My mouse doesn't want to work. Over ED, right?
Yes, sir. Is equals
Oh.
to
Over ED. Okay, that is equal to what
E
was it?
EB
Oh, you. You are saying EB
over BC,
over BC.
which is proportionality theorem, prop theorem.
And then you state your
Um,
parallel lines.
yes, and then
Oh, nice.
I would substitute 16 by EF.
Oh, okay, and then play around your maths now, cross
Yes, and then cross
multiplication.
multiply ED, get
EF.
the
Oh,
length.
then now without any reason, complete that statement. The triangle EFB is similar to what triangle?
So EFB, okay,
Mm-hmm.
EFB is similar to EDC. No,
Okay, absolutely correct. Yeah, I
yeah,
agree. I agree.
EDC. Say.
I agree. Hence, with reasons, I think determine the length of DC.
DC.
You're going to do exactly what you did on that previous question that you were not sure of.
Yes, sir.
Can you try
Cross
that
multiplying
10.5? Oh, it's
and
a
playing
bit
around
tricky.
with the numbers.
10.5? Can you try it? Or it's a bit tricky.
10.5.
Yeah, can you see how is it? But I think it's going to be tricky.
Let me see, sir, first.
Oh, okay. Okay, let me just not doubt you. I believe in you. You're gonna do this question.
It is tricky though, sir. Okay, the
Uh,
area
but
of
but but yeah, tomorrow
triangle.
we are going to look at these kind of questions. We are going to just be on this kind of question and we're gonna kill them, eh?
Okay, sir.
Definitely said. So any question that you have with regarding today's lessons, I don't wanna leave you unsatisfied.
No, sir, I understood everything.
Are you sure?
Yes, sir.
Uh, sure. Don't be shy to say no, sir. Maybe I didn't understand part A, part B, or whatever you didn't understand. Are you sure?
I understood, sir, I'm sure.
Oh, okay, then let me just log out then. Enjoy the rest of your weekend. I will see you again tomorrow.
Thank you.
Oh,
Bye.
oh, cheers, man. Mr. M, I'm logging out. Now, Mr. M.